is a pair of our frequency extenders, okay, and I've got them connected right now to a Copper Mountain 20 gigahertz VNA. All right, these are E-band extenders, 60 to 90 gig, and they've got the proxy flanges on the fronts here, that you can see. Okay, and if you look here, I'm going to bring up our insertion loss chart. I'm just going to use two fingers, right here. I'm going to slide these together. Okay, and you can see my insertion loss at this point right here. It's sitting at, gosh, less than 0.01. I'm going to pull it apart, set it back together. Less than 0.01. It's very repeatable, very stable. It's nothing, there's no black magic hiding behind the camera. This is just a very stable, repeatable procedure that lends itself well to manufacturing. And by doing a process like this, you get rid of those screws, like Wendy mentioned, that can be difficult to get to, that can cause caulking issues, that can scratch components, hurt plating, and this really helps with component manufacturing, so that you're delivering a part that is not damaged or harmed, even if that damage or harm can only be visible and not hurting the performance. At least it does deliver a quality part. So what I'm going to do, I'm going to drop in. I have a band filter here, okay, with a standard flange on it, okay, and these flanges are the proxy flange that has that machined in piece or around the waveguide port that creates an RF choke around the signal that allows this to function well. Okay, so I'm going to go ahead and I'm just going to drop this in. Okay, just going to slide this to it, and you can see the band that's being passed here. You can see our loss is 1.8 dB, 1.84, 1.85. Okay, slide these apart, pull it out, slide it back in. 1.84, 1.85. Very, very easy, very simple. The hardest part is lining up those dowel pins. 1.84, 1.85. Let me turn this around. .83, 1.82. Very stable, very clean, very simple. You can set this back, and we'll go back to 0.01. So this is, as Wendy mentioned, this system is available in several configurations. We're looking at all the motorization of it and the offset guides for it. The bottom line is that this rail, when coupled with these, it's designed specifically for the frequency extenders, but really what it does, it creates consistent, reliable, repeatable connections for testing and just makes things so much easier for your folks who may be in manufacturing and trying to produce a higher volume. I mean, you can see how much easier this is than screwing in and out parts. Increases productivity. The results, your test results are more consistent. You save wear and tear on the flanges on the parts. And again, like Wendy mentioned, this is something we developed in our own process that we saw a need for, where we were having issues with parts, either damaging them them, hurting them, or, just, simple operator error. We're all human. So the more we can take some of our errors out of it, and this is a system that certainly does that, certainly does it well.
Thank you so much for that presentation. Craig, that was really cool.
This young man speaking, Wendy, sorry. Thank you, Craig. Craig, would you be able to put the filter back, but show a little bit of dynamic range of this rejection?
Sure.
Yeah,
sure, I can do that.
A couple of things I want to mention helps the folks. One is about the calibration, right? So we all know at the high frequency terabits, WR6, 5, even W band, the calibration could be a little tedious, right? Sometimes depends on the operator, how much stress you put on the screw. If the friend has a little bit of caulking, you could try and repeatedly trying to see how so we have a skilled engineer to those categories. So with the contactless frame, pretty much everybody can do it. It becomes effortless. Then on top of that, I also believe, not only for the DNA, right, for many test equipment, whenever you need a good connection, that's leaking, then you all be able to use contactless flange. So to me, most of the high frequency millimeter wave terabits, we've got interface. Test port should be equipped with the contactless flange. With that, you can eliminate a lot of operators error, kill, training, and all those things. Yet your DUT performance is going to be consistent. There will be no doubt. Like for us, when they mentioned we produce hundreds isolators a week, sometimes power divider, sometimes filter, always has a doubt whether the data is taking, accurately. So those are a couple of things I want to mention. Thank you. So right now, Freq is showing, I do not know if Freq can change here. Is it enough to 10 dB per division? If it's too hard, that's fine. If anybody is advanced, we can, okay. So this is basically showing the dynamic range pretty much of the extended. Okay, I think that's all I need to say. Thank you, Craig.